Okay, we're going to walk through our introduction to the next unit, which is about the unit circle and non-right triangle trig. And you should watch this video after you watch the video that's entitled "What is a Radian," which is the learning activity, which is mentioned up above here. So the learning activity in the first video goes through the activity that's on the link that I just highlighted. So if you want, you can walk through that. I went through that with some explanation in the other video on the link that I sent you. So I'm going to summarize that activity right now. So we measure angles in both degrees and radians. So I want to summarize what is a degree and what's a radian. And going forward, you need to be comfortable with measuring angles in both of these units. So first off, what's a degree? So a degree is based on an arbitrary value that there are 360 degrees in one revolution. And that's somewhat arbitrary, which means that 1 degree is equal to 1/360th of a revolution, or we might say of a circle. Okay, and that's the definition of a degree. What's a radian, on the other hand? A radian is defined based on characteristics of a circle. So a radian comes from the word, we can think of this as a radius angle. That's where the word radian comes from. So we're taking the radi here and ang from angle. So a radian, think of it as a radius angle. What does that mean? Right? So a radian is defined as the angle or the amount of rotation we need such that the arc that's intercepted has a length that's equal to the radius. So this piece right here has a length that's equal to the radius. If I take that length and I put it along the circumference of the circle, so let's say that arc has a length of 1 radius, then the angle here, I'll call it theta, is equal to 1 radian. Okay, so I'll write that out for you. So a radian is the angle that intercepts, that means so that the arc length that's cut off by the angle, an arc with a length equal to the radius. That's the definition of a radian. You can also think of it as a radius angle. Okay, and also what was shown in that introduction is that there are 2 pi radians in a revolution, and that means there are 2 pi radians in 360 degrees. And if we divide both sides of this equation by 2, we'll get that there are pi radians in 180 degrees. And that's going to be the conversion factor that we're going to be using going forward. Okay, so that's definitions of a radian and a degree. So what we're going to do now is a bit of a review of the angle measures associated with the unit circle. So this diagram here should look familiar. And what I'm going to do, and you can stop the video and try to do it on your own, I'm going to go around the circle and first measure or label all the angles in degrees. And I'm going to do it in a certain fashion that we can repeat the method and do the same thing for radians and have it make sense. So we start always at the horizontal. So this is going to be 0 degrees. If we were to go all the way around, it's 360 degrees. So I'm actually going to label this with 2 degree measures. The next place I'm going to go is if we cut that circle in half. If we cut it in half, we'll be at this point. And if we cut that in half, we'll be at half of 360, which is 180 degrees. The next thing I'm going to do is I'm going to cut that half. So the 180 degrees, I'm going to cut that in half. So half of 180 will put me at the top of the circle. And half of 180 is 90 degrees, which is our right angle, 90 degrees. Now I'm going to count by 90s. So I'm going to start at 0. A quarter of the way around is 90. 2 times 90 is 180. I'm going to add another 90 to my rotation. So 180 plus 90 will put me at the bottom of my circle, and that's going to be 270 degrees. And if I go all the way back around, I'm back at 360. The next thing that I want to do is I want to cut the 90s in half. The 90 in half are the points in the middle. We've got these cluster of 3 angles here. The middle ones are going to be ones that are cutting 90-degree angles in half. So I'm going to cut the first 90 degrees in half. 90 divided by 2 is 45. So that's going to be 45 degrees. And so now I'm going to count by 45 degrees. So 45 degrees is here. 2 times 45 is 90. We've already labeled that. I'm going to add another 45 to my 90. 90 plus 45 is 135. If I add another 90 degrees, I'm at 180. I add another 90 degrees, so I'm sorry, I add 45 degrees. I misspoke. So 90 plus 45 is 135. 135 plus 45 is 180. Add another 45. 180 plus 45 is 225. Add another 45. We've already labeled that as 270. Add another 45. That's going to be 315 degrees. Now we've labeled all the multiples of 45. The next ones that I want to label are going to be multiples of 30. And I know that this amount of rotation is 30 degrees because I can count how many I have halfway around. So going halfway around, I have 1, 2, 3, 4, 5, 6 of this amount of rotation. 180 divided by 6 is 30. So this piece is going to be 30. So that angle's 30. If I go to the next open spot, that's 60. If I go 30 more, I'd be at 90. That's already labeled. I go to the next one that I haven't labeled. 90 plus 30 is 120. The next open spot is another 30 degrees away, so that's 150. If we go another 30 degrees, we're halfway around, which is 180. We go another 30 degrees, that's going to be at 210. Another 30 degrees will put us at the next one that we haven't labeled, which is 240. Another 30 degrees will be at the bottom of the unit circle. We already labeled that. The next one that's not labeled will be 270 plus 30. So that's going to be 300. And then the last one will be 300 plus 30, which will be 330 degrees. And now we've labeled this circle in terms of degrees. We're going to do the same exact exercise now, but in terms of radians. Okay, so from the learning activity, we know that there are 2 pi radians in 1 full revolution. So I'm going to label the 0 degree or 360 degree as 0 radians or 2 pi radians. And I should mention that if there are no units, so if no units are written, that means it's in radians. If you're writing an angle in degrees, you must use the degree sign. So if nothing's written here, like 0 and 2 pi, that means they're radians. Okay, so we're going to do the same activity as we did in terms of degrees. So if we go halfway around the circle, so we go right here to where we have 180, we go half of 2 pi, which is pi. So 180 corresponds with pi. Now I'm going to cut the half in half. So I'm going to cut the amount of rotation of pi in half. So I'm going to be where the 90 degrees is, and that is going to be pi over 2. Okay, so every time I go 90 degrees, I go pi over 2. So if I'm at pi radians when I'm halfway around, I go another 90 degrees, which is another pi over 2. So I'm at pi plus pi over 2. So that's equal to 3 pi over 2. And that's how we normally label it. So it's 2 pi over 2 plus pi over 2, which is 3 pi over 2. And now we've labeled all the quarter of revolution angles. The next thing we're going to do is we're going to cut the pi over 2, that amount of rotation, in half. So if we cut that in half, that's going to be half of pi over 2. So let's see, half times pi over 2 is going to be pi over 4. So 45 degrees is going to be the same as pi over 4 radians. And now I'm going to count by pi over 4. So 45 degrees is pi over 4. If I go that same amount of rotation, I'm at 2 pi over 4, which I simplify to pi over 2. I go another pi over 4. That's at, now I'm at 3 pi over 4. I go another pi over 4. That puts me at 4 pi over 4, which I simplify to pi. The next one is going to be 5 pi over 4, which I can't simplify, so 5 pi over 4. I go another pi over 4, so that puts me at this 270. That would really be 6 pi over 4, but 6 pi over 4, I can divide 2 out from the numerator and in the denominator. That's going to be 3 pi over 2. And the last multiple of pi over 4 is going to be 7 pi over 4. 6 pi over 4 plus pi over 4. Okay, just like with degrees, when we counted by 30 degrees, we're going to count by that amount of rotation in terms of radians. So what is that? So let's see. 30 degrees, remember, it was 1/6 of 180. So 30 degrees is also the same thing as, it's the same thing as 1/6 pi. So 30 degrees is going to be, we're going to write it as pi over 6. That's how we usually write radians. And now I'm going to count by pi over 6. So 30 degrees is equivalent to pi over 6. If I rotate another pi over 6, I'm at pi over 6 plus pi over 6 is 2 pi over 6. But 2 pi over 6, I can simplify that to pi over 3. The next one, remember, you have to remember where we were. We were at 2 pi over 6, and then 2 pi over 6. If I add one more pi over 6, will put me at 3 pi over 6, which is pi over 2. We've already labeled that. The next one, I'm going to add another pi over 6. That's going to make it 4 pi over 6. But 4 pi over 6, I need to simplify, so that's going to be 2 pi over 3. I'm going to go to the next one. So I'm going to rotate another pi over 6 radians. Remember, we were at 4 pi over 6. Now we're at 5 pi over 6. That can't be simplified. We're going to add another pi over 6. So 5 pi over 6 plus pi over 6 is 6 pi over 6, which we simplify to simply pi. We're going to go another pi over 6. So that'll put us at 7 pi over 6. Then we'll go another pi over 6, which will put us at 8 pi over 6, but we can simplify that. So 8 pi over 6, I can divide out a 2, so that's going to put us at 4 pi over 3. Go another pi over 6, that'll be 9 pi over 6, which will simplify to 3 pi over 2. The next one, we were at 9, so now we're at 10 pi over 6, but 10 pi over 6 simplifies to 5 pi over 3, so we'll get rid of that. Then we'll go to, remember we were at 10 pi over 6, we'll rotate another pi over 6, so that'll put us here, and that will be at 11 pi over 6. And if we add one more pi over 6, we'd be at 12 pi over 6, which is 2 pi. And you're going to have to be responsible for understanding these angles on what we're going to use as a unit circle in degrees and radians. Okay, let's go on to the next page. So on the next page, we have a few problems. So it says approximate 40 degrees in radians, no calculator, give your answer without using pi. So let's just think about this. I'm going to draw, approximate a 40 degree angle, which that I'm comfortable with, right? So 40 degrees is about here. And then I have to think, how many radians is this, right? And I knew before that I had, this was 0, this is pi, which is also 3.14 in terms of radians. Up here is pi over 2, which is about, if you divide that out, 1.57. So how much of a radian have we gone? You know, if 45 would be half, that would be pi over 4. We've gone a little less than a half of 1.57. So I don't know, I'll make up some guess. Maybe it's about half of 1.57 would be what? Like a little less than 0.8. So it's less than 0.8. Let's say that this is about 0.7 radians, just as an estimate. Okay, if we actually want to calculate this using a calculator, we can use a conversion factor. Okay, and the conversion that we're going to do, it's going to be like we learned in chemistry. So if I have 40 degrees and I want to convert to radians, I'm going to use a conversion factor that there are 180 degrees per pi radians. And I'm going to put the degrees in the denominator because I want the degrees to cancel out. So now my units cancel out. And so this will be 40 pi over 180. And if you enter that in your calculator, that actually turns out to be 0.7 radians. I didn't realize I was making such a good approximation up above. But you could guess something else, rather than 0.7 radians. Okay, the next problem is a good number to have in mind when estimating is the number of degrees in an angle of 1 radian. So let's figure that out. So if we have 1 radian and we want to convert that to degrees, we're going to multiply by our conversion factor. So 1 radian, and then I need to remember there are pi radians in 180 degrees. And I'm going to put the radians in the denominator so they cancel out. So there are 180 degrees per pi radians. And if you enter that in your calculator, you'll get 57 degrees. And this is a good thing to remember. So 1 radian is about 57 degrees, which would have helped us had we known that in this problem up above, right? So if we know 1 radian is about 57 degrees, so if 1 radian is about 57 degrees, then we know that 40 degrees is about 2/3 of 57. So we could say 40 degrees will be about 2/3 of a radian. That's another way. Once you memorize that 1 radian is 57 degrees. And I remember that. So I think that would be a really good thing for you to remember. So remember that 1 radian is about 57 degrees. That'll help you when making approximations. Okay, let's look at the next problem. Number 4. Johnny thinks that the terminal side of an angle of 3.3 radians lies in the second quadrant. Explain to Johnny why he is wrong. Okay, so we have to figure out where is 3.3 radians. So remember that if we go halfway around the unit circle, well, first remember that if we go all the way around, 2 pi is 1 revolution. So if we go halfway around, it's pi radians. So halfway around would be pi radians. And pi is about 3.14. So if we are rotating 3.3 radians, that's going to be more than pi. So 3.3 radians is going to be a little more than halfway. So if we go a little more than halfway around, we'll be in quadrant 2. So quadrant 3. The 3.3 radians will be in quadrant 3 because 3.3 radians is a little more than pi, and pi radians is halfway around. Okay, let's go to the next page. And I will make this bigger. Okay, angles such as 30 degrees and 390 degrees are called coterminal. And you should have learned about coterminal angles last year. So I'll just review that. They're called coterminal because their terminal side is in the same place for both angles when drawn in standard position. So if they're coterminal, they end at the same spot. Okay, so let me draw, like this is 30 degrees, and then if I wanted to draw 390 degrees, that would be a full rotation plus 30 degrees. So these angles are coterminal because their terminal sides coincide. So problem 5a asks us to give two angles coterminal to pi. So I'm going to draw an angle that is pi. So this would be pi, right? Pi is halfway around. And if I want angles that are coterminal pi, I have to stay in the same units. It's easier to stay in the same units. So what I can do is I can add a full rotation. So I'm going to do that. I'm going to do that in green. So that would be pi plus 2 pi. That's a full rotation. So a positive coterminal angle is going to be pi plus 2 pi, which is 3 pi. So to find a coterminal angle, you can add or subtract a full revolution. So a full rotation. So add or subtract a full rotation, which here is going to be 2 pi. Another coterminal angle would be, I could think about rotating in the negative direction. So I could start here and rotate, and that will be negative pi. So I could have a negative coterminal angle, and that's going to be pi minus 2 pi, which is negative pi. Okay, so those are two coterminal angles, negative pi and 3 pi. So to find them, you add or subtract a full rotation, in this case, which is 2 pi, if the units are in radians. Give two angles coterminal to an angle of 5 radians. So 5 radians, I'm going to sketch that. So if I have 5 radians, if I went all the way around, I'd be at 6.28 radians. So 5 radians is somewhere in the 4th quadrant. So let's say that this is 5 radians. If I want a coterminal angle, I will add and subtract a full rotation, which is 2 pi. So I can do 5 plus 2 pi. So I'll show that. So we're going to go a full rotation more. So 5 plus 2 pi would be, if you punch it in your calculator, it's 5 plus about 6.28. So I could say that's about 11.3 radians. And I can also rotate in the negative direction. So that would be just this little piece here. That would be 5 minus 2 pi. So that would be 5 minus 6.28, which is about negative 1.3 radians. Okay, last problem. So a fly, let's call her Amy, crawls on a wheel of a bicycle with a radius of 34 inches. So I'm going to make a sketch. So I have a wheel and the radius is 34 inches. And let's see what we're trying to find out about this. So Amy crawled 68 inches along the circumference of the wheel. So if she crawled 64 inches, that would be 2 times the radius, right? So we'd go 1 radius, 2 radius. So this would be 34 inches and 34 inches for a total of 68 inches. And we want to know the measure of the angle in radians. And to solve this problem, so we want to know this angle, this theta in radians. To solve this problem, we have to think about the definition of a radian. So remember, a radian is an angle that intercepts an arc with length equal to the radius. So Amy has actually crawled an arc length equal to 2 radii, right? So this angle theta is going to be 2 radians because the arc length that she's traveled, so this 64 inches, is 2 times the radius, right? Because she's traveled 2 times the radius. Okay, letter B. Amy crawled a little more, a total of 85 inches. Now what is the measure of the angle? Okay, so really the number of radians is just going to be how far she traveled over the radius. So we need how far she traveled. So this is going to be, so we really want to know number of radii traveled. That's what we want to know. So she went 85 inches over 34 inches. And if you punch that in your calculator, that turns out to be 2.5 radians. That's how far she traveled. And letter C, Amy's friend Bob made an angle of 1.3 radians. How far did Bob travel? Right, so I can convert this. I can say 1.3 radians. Every radian that he travels, he's going to be traveling 34 inches on the circumference, right? Each time you travel 1 radian, you travel the radius. And if you multiply this out, it turns out to be 44.2 inches.